Hello, today we would like to show how we obtain the relative permeability curve using scale analysis. But first, let's meet the team.
Rock properties. Capillary pressure is the pressure generated by two immiscible fluids in a narrow channel or tube under the influence of adhesive force. Here is three beakers with an oil and water system that shows its capillarity. For the first one, it is water wet due to the high rise of water in the capillary tube. This is because of the high adhesive force rather than its cohesive force between the molecules and the wall. And the second beaker is intermediate wet and the third beaker is oil wet. For the last beaker, you can notice that the water level is lower than the normal level. This is because the oil is pushing down the water level due to its weight. Centrifuge is one of the lab measurements of capillary pressure. The core sample is saturated with a wetting phase and is placed in a cell surrounded with non-wetting phase. Then, the capillary pressure was set into a different level by controlling the centrifuge speed from low to high speed. When the saturation is stable at each speed level, water collected was measured and stability will be obtained up to 24 hours. And the last saturation was collected and weighed, and the rotation speed is converted to capillary pressure. Another method is called porous plate technique. The inlet will be oil pressure and the outlet is water pressure. The capillary pressure will be the difference between oil and water pressure, which is water wet. Starting with low capillary pressure, the water saturation is calculated when it reaches equilibrium and slowly increase the capillary pressure until it reaches irreducible water saturation, also known as connate water saturation. And for the last method that we are going to mention is mercury injection capillary pressure, MICP. For this method, the core sample is placed inside a pressure chamber and mercury is injected through a pump. Then, the volume of the mercury injected and the pressure is calculated.
Now I'm going to talk about relative permeability. So relative permeability is the ratio of permeability of the substance to absolute permeability. To measure relative permeability, the experiment was performed at room temperature with net Hassler pressure of 15 bar using unsteady state method. Using a back pressure of 10 bar, humidified gas will displace the water at a constant differential pressure. Then flooding was maintained until fractional flow of water was negligible. Lastly, Klinkenberg corrected air permeability will be used at irreducible water saturation and is used as the base permeability. For a special core analysis report, which we can call SCAL report, it is any laboratory measurements either on whole cores or core plugs that are not part of a routine core analysis generally fall under the category of special core analysis report. It will measure properties of rocks such as relative permeability, wettability, and capillary pressure. As you can see, we use the samples data to measure relative permeability curve.
Okay, so from capillary pressure result, we use three methods to find relative permeability curve. So the first method is Purcell approach. In the Purcell approach, as you can see in the formula, we first need to find 1 hour pc square versus water saturation graph. After that, you need to find the area under the graph for each water saturation. After we find the area, we need to divide all the areas with the total area from the cumulative area. The area for each water saturation divided by the total area is the permeability for KRW and KRNW. As you can see here, this is our data and our graph. The next method is Burton approach. Burton approach and Purcell doesn't difference that much. Burton approach just add lambda RW or lambda RNW. The lambda we get from the tortuosity of 1.0 water saturation and tortuosity of SW at that particular point. The method is the same. You also need to find the area under the graph, and as you can see, this is our data and our graph.
Last method that we use is correlative permeability model. Since this process represents the drainage process, so we use the normalized wetting phase separation formula equals to SW minus SWR over 1 minus SWR. Next, we can calculate the KRW and KRNW by using the normalized wetting phase separation that we got. Here is a graph of our calculation. So the conclusion that can be made from this project is we can determine the relative permeability curve from the capillary pressure data by using three methods, which are using Purcell method, Burden method, and correlative method. Due to the Klinkenberg effect, the result that we obtain may vary, and the calculated results indicate that Purcell method is the best fit to the experimental data of the wetting phase relative permeability, which is independent of the fluid system and the gas separation history.